Hey everyone, welcome to this explainer. Look, the stakes for the 2025 IBPS Specialist Officer IT exam are literally as high as they get. If you're aiming to secure that coveted IT officer position, you already know the syllabus doesn't just skim the surface. I mean, it digs deep. We're talking about a seriously rigorous test that covers everything from foundational memory allocation and core programming logic, all the way up to the absolute cutting edge of generative AI and cloud infrastructure. So today, we're going to use the actual memory-based questions from the recent 2025 exam as our guide. I'm going to challenge you to really test your knowledge as we work through this interactive explainer together. My ultimate goal? To make sure your conceptual foundation is absolutely rock solid. Okay, let's dive right in by outlining our 4 main tech pillars for today. We'll be hitting security and disaster recovery, networking and web basics, core programming and algorithms, and rounding it out with data, cloud, and AI. Let's get to it. Pillar 1, security and disaster recovery. This is where we tackle the critical protocols that dictate exactly how enterprise systems stay alive, compliant, and highly secure. Let's kick things off with a disaster recovery scenario, drawn directly from question 4 in our source material. Imagine a severe server crash just completely wipes out your primary data center. In disaster recovery planning, there's a very specific metric used to define the absolute maximum acceptable amount of data loss, and it's measured strictly in terms of time. Do you happen to know the acronym for this crucial metric? Right, so the answer is RPO, or Recovery Point Objective. Basically, if an organization has an RPO of 4 hours, that means they run their backups frequently enough that if a massive disaster strikes, they're going to lose no more than 4 hours worth of data. And what's also incredibly important for the exam, this was actually tested in question 2, is knowing that a disaster recovery plan is a foundational piece of business continuity planning under the ISO 22301 standard. That specific ISO standard is essentially the gold standard for keeping a business breathing, and setting a strict RPO is a huge part of the whole shebang. Now, you absolutely need to know your access control models cold. Here's a rapid-fire cheat sheet for you. Zero trust is exactly what it sounds like. Never trust, always verify. You basically operate assuming a breach has already happened. Discretionary access control, or DAC, leaves the access decisions entirely up to the data owner. Mandatory access control, MAC, is way stricter. It relies on rigid security labels and classifications. Think military-grade clearance. And finally, role-based access control, or RBAC, simply assigns permissions based on a user's specific role within the organization. All right, let's pivot to some highly targeted cyber threats. A really common exam topic revolves around this fascinating, incredibly predatory tactic. The question is simple, but it demands precise knowledge. What exactly is a watering hole attack? Well, a watering hole attack is when hackers infect a commonly visited website just to target a specific group of users. Instead of going after the users directly, which, can be super tough if they have strong personal security, the attackers compromise a site they know the target group already hangs out at. It is quite literally like a predator waiting in the bushes at a watering hole out in the wild. When the unsuspecting targets arrive to drink, or in this case browse, boom, they get infected. Moving on to Pillar 2, networking and web basics. Because if you don't grasp these underlying logical foundations, you simply can't manage a network. Let's look at email handling and the core difference between these two protocols. SMTP, or Simple Mail Transfer Protocol, is strictly for sending emails outward across servers. On the flip side, POP3 is the protocol used by a user agent to download those emails locally straight to a device. An easy way to remember it? SMTP pushes it out, POP3 pulls it down. Simple as that. Now, for some quick network math from question 10. Imagine you're managing a network where the maximum transmission unit, the MTU, is rigidly set to 1500 bits. It's a super common threshold. But what happens if a much larger data packet, let's say 2000 bits, needs to transmit across this specific network? Well, because of that strict 1500-bit threshold, the network just can't swallow the 2000-bit packet whole. It naturally splits into 2 distinct fragments. Assuming there's no header overhead to complicate the math, the first fragment maxes out the MTU at exactly 1500 bits, leaving the remaining 500 bits to travel in a second separate fragment. Truly understanding this fragmentation process is absolutely vital for troubleshooting network latency and packet loss. All right, time for Pillar 3, core programming and algorithms. We're digging into the sorting mechanisms and code execution rules that actually power these applications. Question 23 from the exam goes really hard on testing your grasp of Java method binding. When dealing with method binding, you've got to recognize the trade-offs. Static binding gets resolved at compile time, which makes it significantly faster when it comes to execution. But dynamic binding is resolved at runtime. Sure, it might be a tiny bit slower, but dynamic binding is absolutely essential because it's the very mechanism that allows for method overriding in object-oriented programming. Let's challenge your algorithm knowledge with a classic computer science concept from question 29. You know how almost all the sorting algorithms we learn early on, like quicksort, merge sort, or insertion sort, they all work by comparing elements against one another to figure out their order? Well, which popular sorting algorithm doesn't compare elements against each other at all? The answer is radix sort. Radix sort totally bypasses traditional comparison operations entirely. Instead, it sorts data by processing individual digits or characters, just grouping them bucket by bucket. It completely breaks the mold of comparison-based algorithms, which is exactly why exam setters love throwing it into the mix. Finally, we reach Pillar 4, Data, Cloud, and AI. Let's take a hard look at the modern IT landscape, focusing on massive data handling and artificial intelligence. Let's trace a database transaction step by step, exactly how it was presented in question 44. Okay, we start with a bank balance of $1,500. A transaction begins, and crucially, you drop a save point right there. Next, you add 100 to the account, but wait, before we finish, a rollback to save point command is executed. And then finally, a commit is issued. Because of that rollback, the addition of the 100 is completely undone, reverting the state right back to the save point. Therefore, your final account balance remains exactly the same, $1,500. Now, let's look at another database scenario, this one from question 51. Imagine you're making a bank transfer. The system successfully debits the money from your account. But in that exact millisecond, right before it can credit your friend's account, the system just crashes. The money vanishes into thin air. Which core database rule from the famous ACID framework did we just blatantly break? That right there is a textbook violation of atomicity. Atomicity is the database property that guarantees a transaction is treated as a single, indivisible unit. It is strictly an all-or-nothing operation. If the debit happens, the credit absolutely must happen. If any single part fails, the entire transaction has to fail and leave the database completely unchanged. Moving to the absolute cutting edge, the exam is clearly adapting to the times. Question 40 hits on a concept that is completely foundational to the current boom in artificial intelligence. Do you happen to know what generative AI models utilize as a latent space? So, latent space acts as this intermediary, abstract space. When you're using generative AI, the model doesn't just memorize data, it compresses and represents the data in this hidden, multidimensional space. It's actually within this latent space that the AI truly grasps the incredibly complex underlying structures and relationships of the data. And that is what allows it to generate those entirely new, realistic outputs just by navigating this abstract area. Wow, we have covered a massive spectrum of the IT landscape today. We journeyed from the bedrock of disaster recovery and network fragmentation straight through to the tricky logic of database rollbacks, all the way into the abstract realms of generative AI. I want to leave you with one final thought to ponder. The line between traditional foundational networking and abstract AI is blurring faster than ever. As technology systems start writing their own code and generating their own data, will our traditional IT rules still apply? Or are we on the absolute verge of needing a completely new rulebook? Keep testing yourself, keep adapting, and you're going to be more than ready. Thanks for joining me on this explainer.